How it is that Mercury is both the closest and most difficult planet to reach. On November 3, 1973, a group of NASA engineers experienced an exciting day packed with excitement. They were looking forward to the launch of Mariner 10, an astonishing robotic space expedition that would have done what was previously thought to be impossible: reach Mercury, the closest planet to the searing sun. Mariner 10 will take the 1,100-pound spacecraft by the cloud-shrouded Venus on its way to Mercury, the first two-planet mission ever attempted, according to the New York Times. It will also be the first effort to exploit Venus's gravity as a source of energy to reach another planet. Yes, Mercury was a formidable obstacle, but as you'll see in this compelling video, NASA's great minds won over the odds. They expertly piloted Mariner 10 past Mercury not once, not twice, but 3 times, setting a new record in the process. The last flyby, on March 16, 1975, was particularly impressive because it placed the spacecraft within 203 miles or 327 kilometers of the planet's surface. The effort to reach the solar system's core planet would never be the same again. NASA opened the way for future missions, leaving an everlasting influence on the history of space travel. Follow me in this video to see why it was so difficult to reach Mercury and what solutions people devised to solve the challenge. Hello and welcome to Zeey. Subscribe to our channel and ring the bell to receive our daily video. The speed issue. Mercury, our solar system's intriguing core planet, remains largely undiscovered. Can you imagine that only 2 missions, Mariner 10 and Messenger, have ventured to approach this enigma? But stay onto your seats, for another expedition is on the way. Bepicolombo is its name, and it is scheduled to reach Mercury in December 2025. Each of these daring expeditions had to devise its own smart plan to get close to Mercury. It all relied on their objectives and, of course, the propellant they had on hand. Trust me when I say that reaching this planet with no atmosphere is no easy task. The true issue, you see, is reaching the enormous speed required to maneuver a spaceship into a stable orbit around Mercury. Let me explain. In the 17th century, the great Isaac Newton discovered that gravity becomes stronger the closer 2 bodies are. And, in comparison to other planets, Mercury is virtually rubbing shoulders with the Sun. As a result, any probe approaching this scorching planet must contend with the huge gravitational attraction of that blazing star. To give you an idea, the gravitational pull near Mercury is 9 times greater than what a spacecraft feels while circling Earth. It's no surprise that only 3 missions have braved this cosmic voyage so far. It's not going to be easy. Before I explain what other issues can develop, let me tell you how Mariner 10 overcame the speed requirement issue. It made use of gravity assist maneuvers as well as precise trajectory planning. It executed an Earth gravity assist shortly after launch, using Earth's gravitational pull to increase its speed and set the path for Venus. Only 1 month later, the probe made its first flyby of Venus, passing around 3,582 miles or 5,768 kilometers above the surface, boosting its velocity even further. It made its maiden flyby of Mercury on March 29, 1974, coming within 704 kilometers or 437 miles of the planet's surface. At this time, it harnessed the planet's gravity to accelerate even farther and established its path for Mercury. Giuseppe Colombo, an Italian mathematician and engineer who made substantial contributions to the Mariner 10 mission, invented the gravity assist concept. Engineers at NASA's JPL were able to place the spacecraft in an orbit that sent it back to Mercury twice more thanks to Colombo's suggestions. Mariner 10 was grounded on March 24, 1975, due to a lack of fuel. This amazing probe, which looked like a bug-eyed insect in flight, had made it. Mercury's 3 flybys have greatly aided our understanding of the planet. They enabled the detection of a magnetic field and a tenuous atmosphere dominated by helium, as well as offering indications to the planet's iron-rich core at its core. The temperature issue. Our probe will confront various challenges before it can safely reach Mercury, and one of them is speed. Let's take a moment to discuss temperature, which may be a touchy subject. Consider this: it's winter on Earth, and you're getting a little chilly in your warm home. You decide to move closer to the heater to warm up, but this isn't enough. So you disregard caution and practically contact the heater with your body, risking a burn in order to feel warmer. You have to do what you have to do sometimes, right? The same concept applies to the enormous universe. The hotter you feel as you go closer to a hot source. That is also true in our own solar system. Surprisingly, Venus, not Mercury, has the distinction of being the hottest planet. I'll explain why in a later video, but for now, keep in mind that Mercury has some fairly dramatic temperature changes. Things can heat up to a blistering 800 degrees Fahrenheit or 430 degrees Celsius in the sun, and a chilling minus 290 degrees Fahrenheit or minus 180 degrees Celsius in the dark. So if you ever want to send a spacecraft to circle this scorching planet, make it extremely heat resistant. To take on this challenge, you'll need a full army of clever engineers working around the clock. And believe me, that's just the beginning. But remember, every challenge is an opportunity for invention and discovery. For example, here's how scientists working on the Messenger project resolved the issue. The probe was outfitted with a thermal blanket made of a type of ceramic fabric that was wrapped by many layers of plastic insulation. This one-of-a-kind sunshade was built on a titanium frame and was designed to shield and shade electrical components on the spacecraft's sun-facing side from the heat of the sun. Messenger finished its first year-long extended mission on March 17, 2013, after mapping 100% of Mercury. The probe continued to collect scientific data until April 30, 2015, when it was allowed to crash onto the surface of Mercury due to its decreasing orbit. The issue of communication delay. Mercury, Earth's closest neighbor, is actually rather far away. We're talking about a staggering 48 million miles, 77 million kilometers. That's equivalent to stating you're going to your neighbor's house, only your neighbor lives on another planet. The enormous distance between Earth and Mercury presents major communication problems. Consider this: if you sent a message to Mercury, it would take many minutes for it to reach its destination. Then you'd have to wait several minutes for a response. It's like trying to talk with your partner, but they only react after you've forgotten what you said. Controlling and maneuvering a spaceship in real time becomes extremely difficult as a result of this delay. As a result, considerable planning is required when launching a spacecraft to Mercury. You must ensure that all of your ducks are in a row and that you have some autonomous systems on board to assist you. The endurance issue. Even if you do manage to prepare everything, there is always another issue to contend with. The journey to Mercury is far from pleasant. Depending on the spacecraft's propulsion system and trajectory, reaching Mercury could take months or even years. That's like going on a long hike, but instead of a picturesque trail, you are traversing space. The spacecraft systems must be as robust as nails during this long journey. They must be able to resist the severe conditions of space and operate consistently during the journey. Just like when you go on a hike, you must ensure that you are physically prepared and have all of the necessary equipment to withstand the weather. In other words, it must survive the journey into space. So if you find yourself thinking about visiting Mercury, keep in mind that it isn't as simple as jumping in the vehicle and driving over. To make that happen, careful preparation, patience, and a lot of faith in those autonomous systems are required. A word on Bepicolombo. As we near the finish of this movie, I'd want to discuss the final of 3 missions sent to Mercury by humans. Bepicolombo is named after the brilliant mathematician we described previously, whose theories were instrumental in the exploration of Mercury. The mission is a collaboration between the European Space Agency and the Japan Aerospace Exploration Agency, and it consists of 2 satellites, the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter. Bepicolombo will investigate the creation and history of Mercury, as well as the composition of its core. It will also look into the genesis of Mercury's magnetic field, which is currently unknown. In terms of endurance, the spacecraft will take 7 years to enter Mercury's orbit. Of course, it will utilize 9 gravitational assistants to meet the velocity criteria given by the Sun's gravity, the last 6 of which will be done around Mercury. The probe is currently in space and will fly by Mercury for the 3rd time on June 19, 2023. The next one will take place at the end of September 2024. Stay tuned as we track the spacecraft's journey to the planet. Okay, this video ends here. Thank you for your time to watch. Do you want to stay up to date on the Bepicolombo mission? Let us know in the comments section below, and don't forget to subscribe and ring the bell. I'll see you on the channel again soon.